Within the heating and cooling load calculation with Linear, you can define variables at a central point, which are then used in the entire project and thus save you the individual specification at each component. These can be, for example, temperatures, U values, or floor heights, but also define standard areas such as windows, walls, doors, or floors. Likewise, you can also use the room templates to define room-specific calculation values such as heating or cooling temperatures on a project-wide level. In this way, you can react very flexible to changes on the one hand and calculate and compare different variants with just a few entries on the other. I will be happy to show you how much time you can save by using variables. Let's assume that your client is considering using an additional insulation on the exterior walls and wants to know what effect this will have on the heating load. Now, instead of adjusting the U value of the exterior wall in each room, we can see the impact by changing a single variable. Currently, the total heating load of the building is about 73 kilowatts or 42 watts per square meters. At the room level, you can see all the building components associated with the room, like the floor, the ceiling, as well as exterior and interior walls, doors, and windows. Each of these components has a corresponding U value assigned to it, which was either calculated with Linear or is predefined by you. This exterior wall, which is used throughout the whole project, currently has the assigned U value B108. Via the tooltip, you can already see in this view that this corresponds to a value of 1.47 watts per square meter Kelvin. Now we are switching to the master tables and add a layer of insulation here. For example, let's add mineral wool from the large component libraries and set the thickness to 10 centimeters. The improved insulation will now reduce this U value to 0.25. If you already know the U value of your elements, you can optionally use a predefined value by activating this checkbox and adding the value manually. We will use the calculated value from this sandwich wall in this case. Now we've adjusted all exterior walls of this type in one step and can see the effect. As a result, we can see that the improved insulation reduces the heating load by more than 15 kilowatts to about 57.5 kilowatts or 33 watts per square meter. So within minutes, you are able to give your customers the answer to the question to support them in the decision of adding an insulation or not. Another example is the interior room temperatures. Here it is also very easy to calculate the influence that an adjustment of the temperatures has on the heating or cooling load. If, for example, we change the variable T13, which was mainly used here for the corridors, from 15 to 18 degrees, and the temperature variable T31 for offices and conference rooms from 20 to 22 degrees, we see in the result that this leads to an increased heating load from 57.5 kilowatts to 61.5 kilowatts or 35 watts per square meter. Of course, you can also create own variables and use them in your project. So any change at this central point updates all assigned elements throughout the whole project and thus affects the heating and cooling load calculation, since both use the same parametric data model. The principle of variables thus not only helps you to save a lot of time, but also to keep the quality of your designing process high. Input errors caused by forgotten changes to a single component are practically eliminated, and variants can be compared quickly and easily. This is workflow instead of workaround.